Okay, so next topic now is improper partial fractions. The last one was difficult, I know, and this one is difficult too. But it's very similar to the last one, okay? So firstly, what is an improper partial fraction? Well, who remembers what the word proper means when we say proper partial fraction? Yeah, the power on the top is smaller than that at the bottom. So then improper partial fraction is anything that's the opposite of that. So for example, if the powers are the same, or if the powers are on the top is bigger. So I'll show you with an example. Here's our first improper one. We have 2x cubed minus 7x squared minus 14x minus 23 over x squared minus 4x minus 5. Now, how do we take care of that? So before I start, I want to point something out. A useful, simple result. So for example, I could say 10 into 13, well, sorry, I mean to say 5 into 13, that goes twice, and then what's the remainder? 3. Make sense, of course? It's right to say that 13 equals 2 times 5 plus 3, isn't it? My point is, when I do a long division, it is right for me to say that this here is equal to this multiply this plus this. Okay? So if I had something like this, x into y gives me z with remainder or. It is correct for me to say y equals xz plus or. Although simple, a very useful result. So that's just me making a point. You don't even need to write that down, okay? It's just me making a point for what I'm going to do next. So what I'm going to do next is I'm going to do a long division. Yes, for, the quadratic divided into the cubic. Well, this we are familiar with. This will be 2x. This will be 2x cubed minus 8x squared over minus 7 minus 8, so that's x squared, minus 14x minus 23. Next I'll need, sorry, did I do that right?
No.
I feel like something's gone wrong.
10x minus 10x.
I missed my 10x.
2 multiplied by 2x.
Oh, here. So that should be minus 10x. Long day. Alright, so remainder now is going to be x squared minus 4x minus 23. Okay, what do I need at the end now? 1. Because 1 multiply x squared, what is it? X squared minus 4x minus 5, and then remainder 18. Yes. Now, this has a remainder, but that's okay, because as I showed you a moment ago, we know how to deal with it if it has a remainder. What I'm trying to get to now is this new result I have. I have this result now. 2x cubed minus 7x squared minus 14x minus 23 equals 2x plus 1 times x squared minus 4x minus 5 minus 18. You need me to go down, is it? Yeah. If the remainder has x? No, I mean, it's fine if it does, but I think all of the time it should be a number at the end. But I can see why you might say because the x, because I was kind of lucky that the 4 and the 4 and the x squared cancel. No, good point. I think these are always made so that the remainder is a number. It doesn't have to be, but that's how it should work out to be. But even if it wasn't, it's still okay. Still okay. Because all it means is you'll have a x here as well, 18 plus x or something. No big deal. Now, if you look here, that cubic, of course, is the original cubic in the question. So what would I have to do to make this turn into the original question? If you look at the original question, yeah, you see this cubic here? That's what I have up on the board. So I would have to divide both sides by this quadratic, and it makes the question again. So if I divide both sides now, you can see it up the top here as well. Look, if I divide by this x squared minus 4x minus 5, the bit of work, all I've done is to rewrite my question in the form on the right. But you can now see a big advantage of rewriting it, because what happens on the right? Almost, but not quite. You have to split it first before you can cancel. So my original question becomes 2x plus 1 times x squared minus 4x minus 5 over x squared minus 4x minus 5 minus 18 over x squared minus 4x minus 5. Remember? Elementary school. Yep. Now, what happens in the first fraction? Now it cancels. So what you've managed to do is change the original question into this. 2x plus 1 minus, because they cancel, 18 over x squared minus 4x minus 5. Now, after all of that, what situation am I in now? Yeah, well, what do you mean? Yes, exactly. What's that called? You see, now the situation is I have a proper partial fraction. Because the numerator, what's the power of the numerator? Well, it's actually 0 because there's no x. And what's the power of the denominator? 2. So now it's like what you did in the last class, the proper partial fractions. So now what I do as a side problem is that as a proper partial fraction. So now I go to the side, and what was it? I'm going to go back, of course. What is it? 18 over x squared minus 4x minus 5. First, I should find the factors. That's x minus... Oh, don't worry. I'm going to go back to it. I'm just concentrating now on this piece by itself first. Okay. Sorry, what was I saying? X minus 5 x plus 1. Which you know can be written as a over x minus 5 plus b over x plus 1. Now who remembers what to do next? Not divide. You multiply everything by this denominator here. So bracket, 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 like so. So that cancels all of that. The first one cancels the first one, and then the second one cancels the second one. So I'm left with this. 18 equals a bracket x plus 1 plus b bracket x minus 5. Now, what do I let x equal to here? Minus 1. Yeah. So if I use minus 1, I'll get minus 6. So I get b equals minus 3. And then what's next? Let x equal to 5, and I'll get a equals 3. And I solve it. Okay. Yeah, now I'm going to slide back to the left. So now I have this result. I go back to my main question. So returning. Oh, hurry up, come on. Alright. Nah, prison would be better. I'd be allowed to beat him if it was prison. I'm not allowed to beat him as his teacher anymore. Nowadays, it's not something that's allowed. Alright, now going back to the main question. What you've done is, you've expressed this here as the partial fraction. So if you remember, what was it? The a was 3, wasn't it? Over, the a was minus 3? 3. Over, what was the first factor? X plus 5. And then minus 3 over x minus 1. Was that it, yeah? No, it was x minus 5 and x plus 1. So this equals 2x plus 1 minus 3 over x minus 5 plus 3 over x plus 1. X squared minus 4x minus 5. Sorry, that's a cube up the top here. Zoom out. Yes. So what has happened is this. This was my original question, and I've managed to rewrite it in this form. A linear term plus a number over a linear plus a number over a linear. And the reason we're doing this is because if I want to integrate this, I can't. It's too difficult. But if I want to integrate this, I can. It's easy. What's the antiderivative here? Antiderivative.
X squared.
Yeah, so x squared plus x minus 3 log x minus 5 plus 3 log x plus 1. In fact, all of these integrations are in the formula book from semester 1. This is the formula for, I think it was a over bx plus c. That's in the formula book from semester 1. So this is the point. The point is you have a technique to simplify very complicated functions into much simpler functions. And they're exactly the same. Watch. If I put, for example, x is 0, I get here minus 23 over minus 5, which is 23 over 5. And here, if you put x is 0, you get 1 minus 3 over 5 plus 3 over 1, so 3. I mean, if you type that in a calculator, I'm sure it'll give you the same fraction. The two sides are identical. Not only that, they also have the same domain. The domain here is all real numbers except the numbers that make this 0. Okay? And if you look here, the domain is all real numbers except the ones that make this 0. So what x can you not allow here? 5 and minus 1. And it's the same situation here. Okay? So I need you to appreciate that these are actually identical. They're the same thing. This is just simplified. Okay? It's long, but they're all like this. The first step is long division to simplify it. And then you use the previous lesson on the proper partial fractions to simplify further. Now, I'll do another example now in a minute that's more difficult, because all the rest are kind of the same idea, just like the last lesson. So I think the one, I'll jump down to a really difficult one, which will be J. What's that?
That's not finished. We have to do it properly.
No, that's the answer. That's finished. Which matches up with the answer of that. So what I'm saying is the next one I'm going to do is this J one here, which is x4 over x cubed type, okay? Forward?
I'm thinking for this one.
You're thinking about it.
How many hours?
Hours.
Is it B and
What's that?
B?
Yeah, of course. Of course, yeah. It's the section B question. You'll never see this in section A. I mean, it takes too long to do. You know?
This year you are going to do
I'm not doing it this year. I did it last year. I'm not doing the one this year.
But you did in semester 1.
The semester 1, but not the semester 2.
That's
Right. All right. Okay. Next now. So I'm going to do J now. Whoops. So J, the first thing I do as normal is the long division. So I'll just write this down and then I'll give it back to Amjad. It's 21x cubed plus 57x squared plus 79x plus 35. Yes? What's wrong, Andy? Into 21x4 99x cubed plus 134x squared plus 91x plus 23. It's J, isn't it? No, which one is it? Give me the book back. This is J, isn't it? You know the difference between I and J, don't you? What version number does it say on the front cover? then it should be identical. Is this from last time? No, it's Is it just you two? It's just you? That's weird. I don't know how that happens. Yes. Same thing? Out of curiosity, well, that's the case that Amjad's one is different. How many people have J that looks like this with these numbers? And who does not have it? Alright, fine. It doesn't matter. Same shebang. What's wrong with you? It's the same. It is the same. Hang on. No, you're on the wrong page. Can we make sure that number one, we're on page 34. Wait. You're on page 34, number one. Number two, you know the difference between I and J. And number three, you're not stupid. Can you please make sure you have those 3 points? Don't ever become a maths teacher. It's not a good choice. All right. What? Sit down. What? Yes, go ahead. Okay, so going back to this now. So I have to do my long division. So what do I have here first? X. So I'll get 21x4 plus 57x cubed plus 79x squared plus 35x, and subtract 7, 8, 9, 5, 7, 42 x cubed 2, 1, 5, 7, 3, 4, 5 oh man, 55? No. Someone help me out here. 134 minus 79, what is it? 37? Oh. 18, 19, 20, 50, 55, isn't it? Yeah, that's what I thought. Sorry. 55.
That's minus 42.
Minus
No.
26.
Well, hold on. No, it's not minus 42, is it? Because it's 99 minus 57. Yeah. And 134 minus 79 is 55. And then 91 minus 35, 56 x plus 23. And then what do I need next now? Plus 2. Because if I do plus 2, I'd get 42 x cubed. Now this is where I think actually, Amjad, to answer your question, it looks like you're not left with a number here at the end. Plus 114 x squared plus 158 x plus 70. Now this is the remainder. So please, 55 minus 114, 45, 50, 59, is it? What is it? Oh, sorry, you need to scroll over? Sorry, what is it?
59.
Minus 59. Is it minus 49? Minus 59? Yeah. 56 minus 158.
Minus 102.
And then 23 minus 70.
Minus 47.
Right. Now we can use our trick. So now we can say 21x4 plus 99x cubed plus 134x squared plus 91x plus 23 equals something. 21x cubed plus 57x squared plus 79x plus 35 times x plus 2 plus the remainder. Oh dear. Can we still read that? No. Okay. Now, what do I do next? Do you remember the next step? You divide everything by, what's the denominator there?
21x.
Okay, so, well actually I know what it is. It's going to be this, isn't it? Because the same thing's going to happen. When I divide by this cubic, it cancels, and what am I left with? X plus 2. And then I divide here, and I'm left with plus minus 59x squared minus 102x minus 47 over 21x cubed plus 57x squared plus 79x plus 35. And just to save space, I'm going to write Q here to stand for the question, the original question. Now, I have changed my improper problem into proper one. So what I need to do next is get the factors of that cubic. So as a side problem now, calculator please. So like I said last time, this question does not test your knowledge or ability on factoring cubics. That's a separate question. So it is fine to just go straight into the factors here. Mode 54.
53.
53 for quadratic, 54 for cubic.
I think it's 53.
It's cubic. Mode 54. Denominator. Yes. 21, 57, 79, 35. So my first different colour now, as a side problem, and I'll go back to the main one in a minute. So my first one here is 7x plus 5. And then, what's happened? I only have one answer. This is equal to minus 59x squared minus 102x minus 47 over, what did I just say, sorry, 7x plus 5. And then my calculator gives me no other factors. That means what? That the other factor is a quadratic with no roots. How do we find this quadratic? Long division. So now this time as a sub problem, I take this cubic and divide it by 7x plus 5. So as another side problem, what was the cubic, please? 21x cubed plus 57x squared plus 79x plus 35. Is that right? Seems like it. Alright, so what do I have first here? 3x squared. 21x cubed minus 15x squared. I subtract 72x squared. Yeah? 57 minus 15? Yeah. And now what do I have next now? Oh, sorry, and plus 79x. Plus 35.
Why is it 7x minus 5?
Sorry, what did I do wrong? It was plus 5. Is this a plus? Alright, so when I asked you if this was right, this should be plus. So that just changes this here, okay. 57 minus 15, 42x squared plus 79x plus 35. 6 needs to be next, 6x. So now I get 42x squared plus 30x. Subtracting 49x plus 35. What's left? Plus 7. And when I multiply by 7, I get perfect, no remainder. So this is my missing quadratic here. Okay, can I go? I'm going to go back now. Giga. So now I go back to my sub-problem. The problem inside the problem. So this here, what was my quadratic I just got? 3x squared plus 6x plus 7. Now, yes? Inception style. This equals a over 7x plus 5 plus, and then here I get 3x squared plus 6x plus 7. But what do I get on the top? Yeah, bx plus c, because remember, it should be 1 power less than the denominator when you break it up. And let's remind ourselves, what do I have on the left? I have that on the left. So I need to write that down again here. Minus 15, yeah, there we go. Minus 59x squared minus 102x minus 47. All over 21x cubed plus 57x squared plus 79x plus 35. Now I multiply everything by this denominator here. So 2 brackets, 2 brackets, 2 brackets, 2 brackets, 2 brackets, 2 brackets. What happens here? It happens all the time. That cancels the whole denominator. Then which one cancels here? First goes with the first one and second goes with the second. So now I'm left with this. Minus 59x squared minus 102x minus 47 equals a 3x squared plus 6x plus 7 plus bx plus c times 7x plus 5. Okay. Let x equal. So, I could say let x equal minus 5 over 7. If I did this, what would I get? I'd get the a, wouldn't I? That's what I'm, yeah. If I let x equal minus 5 over 7, I could figure out what the a is, yeah? So on the left, I get, or did somebody work it out? Yeah, what's on the left? Minus 2a over 49 equals a, and then if I put it in here, minus 5 over 7. Okay, so 3 dot plus that and plus that. I got, oh, that's nice. I got 208 over 49, so a equals minus 1. I'm going to put that back in to simplify it. Minus 59x squared minus 102x minus 47 equals minus 3x squared minus 6x minus 7 plus bx plus c times 7x plus 5. Sorry, I ran out of space there. I am going to use the second method, the comparing of both sides. So on the right, how many x squareds do I have? Sorry. I have this one here. Can you still see though? Yeah.
Isn't it easy to just make that 0?
We discussed this exact thing last time. Right, and if you want to do that, that's fine. I feel like doing the comparison method, alright? That's how I roll. Sorry. Alright, okay. Now, how many x squareds do I have on the right? Well, there's one here, and then I get one here. When I multiply bx with 7x. So in total, I'll have minus 3 plus 7b x squared. Can you see? Because it's this one and then these two together. Now, how many x's do I have? Well, how many will I have from here? Minus 6. And then what about from this one? I'll have this one here, 5b, correct? Yep. And I'll also have one from here, 7c. Very good. X. And then finally now the constant. Minus 7 plus 5c. And this is the same. So now I make my comparison. But that's handy now, because if you look MB, I can get from this the B, because I have minus 3 plus 7b. What should that equal? Minus 59. And then if I compare this one, what should that equal? Minus 47. So I get minus 7 plus 5c equals minus 47. So here I get b equals minus 59 plus 3 divided by 7. I get minus 8. And there, minus 47 plus 7 divided by 5. I get the c equals minus 8. Now, I can jump up one level and go back to the original problem. Stay focused now. No, stay focused.
What is that? Is the
Same. A equals minus 1. B equals minus 8. C equals minus 8. Let's go back to the original question if we can find it now. Yes. Right. So we're somewhere along. Where's it gone? Wait. Wait! There. Yes. Zoom in. So now I have the A, B, and C. Okay, so what was the A? Yeah, so equals... Oh no, that's not even the original, sorry. That was the sub-problem. The original is back up there. There it is. So this equals, here's our answer, x plus 2, and then here we have plus A. What was A? Minus 1. And what was its denominator? What was it? 7x plus 5. And then we have B and C were minus 8x minus 8. And what was its denominator? It was the quadratic. 2x squared. Yep. Plus 7. What is it? 3x squared. Here, yeah? Now, let's check the answer. Right. It's right.
Yeah.
Scroll down. To what? What last point? Shh! Stop talking! What point do you want? Which one? Oh, down to there. Well, did you write down the answer? You only got to the part where I was with the same piece, yeah? Now, where was that? Let me zoom out. There it is. Here, yeah? Can you see that?
The bx plus c, sometimes b is 0, sometimes c.
Oh my goodness, I'm so tired of repeating myself. I am so tired of repeating myself. No, just listen.
Okay, listen.
Sometimes the B is 0, sometimes the C is 0. Sometimes they're not. Let me tell you when you have each situation. In this situation here, B could be 0, C could be 0, but you don't need to know that at the start. If it works out as 0, you've got 0. And if it's not, it's not. That's fine. But when the quadratic, you see my quadratic wherever it's gone, my quadratic wasn't a quadratic that was repeated. It wasn't like, for example, 2x plus 1 squared. That's a special type of quadratic. In those situations, you need to know which one is 0, the bx or the c, because then you have two answers to consider. Okay? But what I'm saying is, if the quadratic is just a normal quadratic, it doesn't repeat, then you can say bx plus c, and you don't need to know if one of them are 0. Maybe it is, maybe it's not. But if you have the denominator as a square, then one of them should be 0, the bx or the c. You don't know which, and I said in the exam, they will tell you which one. Does that clear it up now?
The answer, yeah.
Yes.
You will analyze the answer right.
The form, yes, exactly, yes. Any other questions? Shh. Any other questions? Now, as you can see, these are very long and very difficult. But as you can also see, the difficulty in this question is keeping track of everything you're doing. Because the only maths that are involved in this question is factorizing, which you can use your calculator for, right? And what else? Long division, which you did in semester 1. So the difficulty in this question is not the maths, it's the management of the maths. Keeping it all in the right places, knowing what you're doing next, keeping track of your work. Okay? So this is a good question, a good practice of just neat management of your workings. Okay? It takes a while to do, but it's worth it, I guess. So what I would like you to do, and I feel it's really important, is that if you spend the remainder of the class practicing these questions, okay? And if you're really, really serious, if you really wanted to, like the last time, go for K to T, the second column down. Alright? And remember, I think I managed to include really every possibility of question you could get. So if you look, I mean, you have, cubic over quadratic, x4 over cubic, and then you have cubic over cubic, cubic over cubic. Really, there's nothing in the exam that will surprise you if you do all of those.
Can we just do look like very difficult? X4 over x cubed.
What does it sound like I would like people to do? Thank you, yes. So get working on that now, Andy. 1 second. 1 second! Unless it's about the screen, is it?
Yeah.
No, so I can close it. Yes.